Alright, this is our second part to our Extrema on an interval lesson. Now, in the last video, we talked about the definition of Extrema. We looked at the extreme value theorem, we defined what relative extrema are, and then we looked at a couple examples. We're going to start this video in a similar fashion where we're going to look at the definition of a critical number. So, we're going to let f be defined at the value c if f prime of c is equal to 0 or if f is not differentiable at c. What we can say is then c is a critical number. So something I didn't talk about in that last video too much was if the derivative is 0 at a specific x value, that means that's a maximum, a relative maximum or minimum to the function. What this definition says is pretty much the same thing. If the derivative is 0 or we can't differentiate at that x value, then c is a critical number, which means it could be a maximum or a minimum. Our theorem, we have another one, 3.2, we're calling the relative extrema occur only at critical numbers. So we state if f has a relative minimum or relative maximum at x equals c, then c is a critical number of f. That's all that says. Now I'm going to give you some guidelines that we can use to find extrema on these closed intervals. So let's do that. Guidelines for finding extrema on a closed interval. Now, we're going to start by saying to find the extrema of a continuous function we'll call f on a closed interval from a to b, we're going to use these steps. The first thing we're going to do is find the critical numbers of f in the interval a, in the open interval a to b. And how we're going to do that is we're going to find the derivative of the function and set it equal to 0. Then we're going to evaluate, and in fact before I do that, I'm going to add a little extra thing to that step 1. Find f prime and set equal to 0 and solve for x. Step 2, we're going to evaluate f at each critical number in the interval a to b. What that means is we are going to use any x values we got from step 1 that are between A and B, as well as using A and B. In fact, what I just put there in step 2, we're not, that last bit, we're not going to use A and B yet. That's actually in step 3. So I kind of combined those two. Step 3 is to evaluate f at each endpoint. So that means use A and B in the derivative. Sorry, not in the derivative, in the original function. And then finally, step 4, we're going to say that the least of these values is the minimum, and the greatest is the maximum. So let's look at some examples of how we would do this. So in continuation from our last video, this would be example 2. We're going to find the extrema of the function f of x equals 3x to the 4th minus 4x cubed on the interval -1, 2. So the first thing we're going to do, find f prime. Find the derivative of our function. So f prime is going to equal, bring the 4 down, we're going to get 12x cubed minus, bring the 3 down, we're going to get 12x squared. So we've found the derivative. We're now going to set our derivative to 0 and solve for x. So we're going to go 12x cubed minus 12x squared equals 0. And to solve this for x, I notice there's a greatest common factor to both terms, and that's a 12x squared. So I'm going to factor 12x squared out, and I'm going to get an x minus 1 equal to 0. And then we're going to set both 12x squared. I'm going to bring this up here. 12x squared equal to 0. And I'm going to set x minus 1 equal to 0. And then I'm going to solve them separately. Well, with 12x squared equal to 0, we're going to get x squared equals 0. We can divide by 12. And the only thing I know, if I square it, that's going to give me 0, is 0 itself. So we're going to find x equals 0. And then in that other one, if we add 1, we're going to find that x equals 1. So we finished step 2. We found our critical numbers. That's also part of step 1 for the guidelines I gave you. But now what we're going to do is we're going to take those critical numbers and we're going to substitute them in to our function. So we're going to find f of 0 and f of 1. Well, f of 0 is going to be 3 times 0 to the 4th minus 4 times 0 cubed. Well, 0 to any power is 0. And if you multiply something by 0, you're going to get 0. So f of 0 is going to just give us 0. Let's also find f of 1 while we're here, and then we'll make some more space to continue our work. So f of 1 is going to equal 3 times 1 to the 4th minus 4 times 1 cubed. Well, 1 to any power is 1, so we're going to end up with 3 minus 4, which means f of 1 is equal to negative 1. So we've evaluated the critical numbers. We also need to evaluate the endpoints. So I'm going to erase some stuff here so we can do those endpoints, so we can evaluate them. And I'm just going to erase this first bit of work we did. So we need to evaluate our endpoints. So we need to find f of negative 1. We also need to find f of positive 2. So let's start with the negative 1. We're going to have 3 times negative 1 to the 4th minus 4 times negative 1 cubed. Well, negative 1 to the 4th is going to give us 1. So we're going to have 3 minus negative 1 to the 3rd is going to be negative 1 times 4 is negative 4. So we're going to make this 3 plus 4, which is 7. And then we're going to also do this with 2. We're going to have 3 times 2 to the 4th minus 4 times 2 cubed. Well, 2 to the 4th is 16. 3 times 16 minus 2 cubed is 8, so 4 times 8. We're going to end up with 48 minus 32, which is going to give us 16. Now, we're going to say whatever the biggest number we got was, that is our maximum. The smallest number is our minimum. So we're going to have a maximum at the point 2, 16, and a minimum at the point 1, negative 1. This is the answer we're looking for. We're going to actually call this video good, but before I close out on this, I do want to point out that there could be some cases where you might have multiple maximums and multiple minimums if the largest number you find happens more than once, or if the smallest number you find happens more than once. So we're done with this lesson on extrema on an interval. I do have a couple more examples we could go through, but I'm thinking they're just more of what we just looked at. So we're good. If you want to see some more examples, see me in class. We can go over them.